Hi, good morning. Welcome to the channel Just Get Civil. We are here for Mission Gate 2021. We are going through a crash course of environmental engineering. Today is the 24th lecture of this series, and 2 or 3 lectures will complete the whole environmental engineering along with the possible problems and all. Before going to the details, I'm Soumyajit dealing with this environmental engineering. Those who are already in the class, And just a reminder that if you don't have the Unacademy learning app in your mobile, go to your Play Store and download it and install that Unacademy learning app. Go for the subscription for the plus courses. Go for the subscription for the plus courses. And while taking the subscription, don't forget to apply the code. While taking the subscription, don't forget to apply the code SEN10. While taking the subscription, don't forget to apply the code SEN10. The batch already started. Those who are actually going for the 2022 के लिए जो लोग कोशिश कर रहे हैं उनके लिए एक बहुत ही गुड न्यूज है कि ऑलरेडी स्टार्टेड द बैच फ्रॉम 28 December 11:15 AM evolve for GATE 2022 in both civil English and Hindi. And while taking the subscription, don't forget to apply. While taking the subscription, don't forget to apply the code SEN10, ACN10, the code SEN10. A batch is launched on 11th January 2021 for the EAC prelim students for general studies. This is a batch A and this is batch B. Same date it started. Both the cases, don't forget to apply the code SEN10, ACN10. Don't forget to apply the code SEN10 for both the cases.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Unacademy Combat is India's largest fortnightly competition for GATE, challenging and original questions curated by best Unacademy educators. Super fast and fun with all India live leaderboard. You can see your rank against others from all over India with a live leaderboard that shows real-time rankings after every question. You can find out what is your position in terms of your preparation. For each and every questions, you will get the detailed video solutions. Don't forget the code SEN10 ACN10, and this is in brief what is Unacademy Combat, and next combat will be on January 26, 2021, 6 p.m. And one more thing I should tell you that I've already taken this class on Saturday 2 p.m. It was a marathon session where gone for this gate rank, boost your gate rank in 5 hours. This particular session consists of those segments like the whole environmental engineering is dismantled over there, and it is shown that how we can deal with the environmental engineering to score maximum from this subject. Please go through that video. It will be helpful for your preparation process only. It will be very, very helpful for your preparation process. Now, so today is the 24th lecture of this water treatment process, this environmental engineering, where we are just going through. We have completed the class discussion, this theoretical discussions of those chapters. Now we have entered to the problem segment, where in the domestic water supply part we have completed quality this water demand and source of water completed in the first event. Quality of water, plain sedimentation, coagulation, flocculation, filtration, it's already done. Certain portion of disinfection is also done. Rest of certain 4 or 5 questions are left still from disinfection and distribution system. These two will be done after this completion of wastewater problems. Today I am going to deal with the problems on wastewater flow rates, and then I will deal with the problems on design of CVATs. Then tomorrow I'll go for the problems on characteristics of wastewater. Then day after tomorrow I'll go for the problems on primary treatment and activated sludge process. Because beyond activated sludge process, for our trickling filter, oxidation pond, septic tank, sludge digestion, and disposal of sewage effluent, these 5 chapters or problems are already done when we have dealt with the chapter itself. Then only 2 things will be left, that is the 4 or 5 questions of disinfection and certain question of this disinfection and certain questions of that distribution system we will be discussing to end this environmental engineering part. So before going to the details of wastewater flow rates, let's have a recap on this process so that you can understand it better. Once again, I am telling you, go to the previous class of this marathon session. It will be very much helpful. There, what are the problems you need to deal? What are the problems you need to remember? What are the key points you need to remember from our chapters? Everything is discussed in details. Wastewater flow rate segment. First, we have gone for the wastewater objective, which is nothing but the draw the wastewater generated from a community and to treat it for safe disposal. The total wastewater generated from a community is called as sewage. We are actually considered around the sewage because we are not considering the industrial wastewater. Hope you remember it. If not, then go for the lecture 11. Once, very short chapter it is. What is dry weather flow? What is wet weather flow? Everything is discussed. And also discuss the different types of sewerage system. Combined system, separate system, partial system. Then estimation of DWF and estimation of SWF. Estimation of DWF is nothing but the population into per capita sewage flow, where per capita sewage flow is nothing but the per capita water supply into a factor. ये factor क्या है? Factor is nothing but the ratio that or the percentage of supplied water converted to sewage. Percentage of supplied water converted to sewage. We are going for the estimation of SWF, where QSWF is equals to AIR by 360. That is the rational formula that we know, where A is the area of catchment in hectare and QSWF will be in meter cube per second. I is the impermeability coefficient, which is nothing but runoff to rainfall ratio, and R is the rainfall intensity in mm per hour, where R is given by an empirical equation 25.4a by T plus B, where T, A and B can be defined by a table given here. And remember, this formula, rational formula, can only be used during the duration of rainfall more than equals to time of concentration. And if the duration of rainfall is not provided, you need to take the time of concentration as the duration of rainfall. This is what is time of concentration I have already discussed, which is time of entry plus time of flow. That thing you can take a note from the class itself. Let's go for the solving of questions. Actually, the today's class. First, we will solve for certain theoretical questions, then we'll go for certain problems. Question number 1 and 2. The liquid waste originating from residential and industrial building are collectively called as sanitary sewage. Four options are there: domestic sewage, combined sewage, sanitary sewage. Done. It will be sanitary sewage. Question number 2. The sewer which transports the sewage to the point of treatment is called as, remember, it is called as outfall sewer. The sewer which transports the sewage to the point of treatment is called as outfall sewer. A combined sewerage system collectively carries. Combined system means carries what? DWF and SWF? Both. So it's storm sewage and sanitary sewage. Domestic sewage and industrial sewage is ideally DWF, but for our case only the domestic sewage is DWF. But don't forget, ideally it is domestic sewage plus industrial sewage. So combined sewage is storm sewage and sanitary sewage. 3D. This is nothing but DWF. Next, question number 4. A sewer which receives the discharge from a number of independent houses is called as. A sewer which receives the discharge from a number of independent houses is called as. Four options are provided: house sewer, intercepting sewer, lateral sewer. None of this. It will be lateral sewer. A sewer which receives the discharge from a number of independent houses is called as lateral sewer. A sewer pipe carrying sewage from a building to the point of its immediate disposal is. A sewer pipe carrying sewage from a building to the point of its immediate disposal is called as. That is called as house sewer, which is carrying the sewage from a building to the point of its immediate disposal. It's called as house sewer. Six. When rainy season is confined to a few months, like that in India, the preferred sewerage system should be. When rainy season is confined to a few months, like that in India, the preferred sewerage system should be what? Separate system, because in those few months the storm water flow will be very high, and partially separate system maintain that particular system is bit difficult. Question number 7. The suitable system of sanitation for an area having uniformly distributed mild rainfalls will be, quite obviously, it's combined system. You know what amount of surface runoff you are going to get. It's combined system. Question number 8. The water carriage system of collection of waste product is preferred to dry conserving system because it is more hygienic in nature. The water wastewater, it's not wastewater coming from kitchens and bathrooms is popularly known as sewage. Sorry, it's domestic sewage discharge. Extremely sorry. The design of sewers in India, the percentage of sewage discharge is assumed as it's 75 to 80% of water supplied from the waterworks. We know that is the factor F. Value varies between 0.7 to 0.8. The peak design flows expressed as number of times their average values will be greater for smaller lateral sewers as compared to these large trunk sewers. Actually, these questions are more for design of sewers, less for this wastewater flow rates, but yes, solve it. The ratio of minimum hourly flow to the average flow of sewage, that is also done. It will be 1/3. Let's go for the revision of design of sewers on, then these questions will be much more easier to you. See, this is a sewer line called as open channel flow inside a closed conduit. The first formula will be used is Chase's equation, where V equals to C under root RS, where C is Chase's constant, R is the hydraulic radius, and to find out the C Chase's constant, two formulas will be used, Cutter's formula and Bagin's formula. And finally, we are coming for the Manning's formula, which is V equals to 1 by N R to the power 2/3 S to the power half, where Q equals to A into V, continuity equation. Where sewage will be 99 to 99.9% of water and 0.1 to 1% of solid. If the flow velocity in the sewer line is not good, then sedimentation, deposition of the solids will occur. It's called as natural sedimentation. So, self-cleansing velocity is actually doing scouring here, because natural sedimentation, whatever particle settling process, is not desired here. And this is the hydraulic elements of circular sewer, where circular sewer is fully filled. depth of flow, area of flow, weighted perimeter, hydraulic radius, discharge, and velocity. And this is partially filled sewer. All the parameters is provided here. When sewer is half filled, these are the components of sewer: inlet, cleanout, catch basin, crowning manhole, drop manhole. And this is the variation of sewage flow that we have already discussed right now. The maximum daily sewage flow is 2 into QDWF. Maximum hourly sewage flow is 1.5 into Qmax daily. Minimum daily sewage flow is 2 by 3 into Q average. And minimum hourly sewage flow is 1 by 2 into Q min daily. Another special case, except sewer, is also discussed here. Okay. Let's go for the problem segments directly, because that's why it's 1 by 3. We have seen that. Question number 13. Point out the wrong statement in the following assumptions generally made by the design of moderate size sewers. First option is given as average daily flow is equals to annual average daily flow. That's correct. Second option is given as minimum daily flow is equals to 2 by 3 of average daily flow. That is also correct. Minimum hourly flow is equals to 1 by 3 into average daily flow. That is also correct. So none of this will be your answer. (14) A space of 1 by 4 to 1 by 3 is left vacant in the design of sewer pipes due to, that is due to what? To accommodate the accidental discharge. To accommodate the accidental discharge. ठीक है? So चार ऑप्शंस देख लेते हैं क्या क्या दिया हुआ है. पहला ऑप्शन है पॉसिबल लो एस्टिमेट्स ऑफ मैक्सिमम एंड एवरेज फ्लो. दैट इज आल्सो ट्रू. तो अगर लो एस्टिमेशन हुआ तो कुछ ज्यादा एस्टिमेशन के लिए जगह बचा रखना पड़ेगा. लार्ज स्केल पॉसिबल इन्फिल्ट्रेशन ऑफ स्टॉर्म वाटर. दैट इज आल्सो एक्स्ट्रा amount of water. accidental discharge. Unexpected increase in population, also accidental discharge. So all of the above will be the correct answer. Option D. All of the above will be the correct answer. Option D. 13, 14, D. 15. The minimum and maximum diameter of sieverts generally adopted in the designs may be in between 15 and 300 centimeter. In between 15 and 300 centimeter. Question number 16. The value of coefficient of runoff for perfectly impervious area. So coefficient of runoff is I. Impervious area means nothing will go inside. So perfectly impervious means perfectly impervious. That means rainfall will equal to runoff. Nothing will be infiltrated. Infiltration is 0. So I is actually equals to runoff to rainfall ratio. If runoff and rainfall are same, that will be 1 only, equals to 1. 16C. Question number 17 and 18. 18 is the problem. 17. With the increase in its duration, the intensity of rainfall will. With the increase in its duration, the intensity of rainfall will decrease if depth of rainfall is fixed. Question number 18. The drainage discharge of a town of 16-hectare area consisting of 40% hard paved. Rational formula equals to what will be computed by rational formula. Okay, let's see. Area is given as 16 hectare. So I overall will be equals to summation of AI by A. That is equals to 40% is hard pave, 6.4 into 0.8 plus 30% is unpaved, 4.8 into 0.2 plus remaining. So remaining is again 30%, 4.8 into wooded 0.1 by 16. That will be equals to 0.41. So they're asking to find out the QSWF. It's AIR by 360, where A will be in hectare, that is 16, I is 0.41, R should be in mm per hour. So it is 5 centimeter per hour means it is 50 mm per hour. Option A will be the correct answer, 0.91 cubic. Question number 19. A minimum velocity should be maintained in seaward 2. That is, minimum velocity means the self-cleansing velocity. Is suspended matter in suspension. Is a 20. A sewer which receives sewage from the collection system and conducts it to a point of final disposal is called a outfall sewer. Question 21. A separate system will be favorable when all the above. Question 22. The sanitation system in which a small portion of storm water is allowed to enter in the sanitary sewage and the remaining storm water flows in separate set of sewage is known as partial separate system or partial combined system. '23. A city with a population of 1 lakh has a rate of water supply 200 LPCD. Assuming 75% of water supply reaches the sewer, the dry weather flow will be. Solve it quickly. Let's see the solution process. So QDWF is equals to population into per capita So that is will be in liter per day. So 10 to the power minus 3 meter cube by 24 into 3600. It will be 0.174 meter cube per second. Option B will be your correct answer. Option B will be your correct answer. Let's go for the next question. Question number 24. A city with a population of 1 lakh has an area of 100 hectare. Rate of water supply is 200 LPCD. The average runoff coefficient for the entire area is 0.5. Time of concentration is 50 minutes. Assume 75% of water supplied reaches to sewer. Find dry weather flow wet weather flow in meter cube per second. Solve it, please. One more question is there. That will be the end of this chapter. Then we will go for the problems from design of sewer itself. Let's solve the question. So first is QDWF, that's population into rate of water supply into factor is 0.75 meter cube by 24 into 3600 meter cube per second. It will come as 0.1736 meter cube per second. Then duration of rainfall is not provided, so duration of rainfall will be nothing but the time of concentration. I will take here. तो क्या करना है पहले, so जिसका वैल्यू है 50 मिनट, तो हमको निकालना है पहले R का वैल्यू, रेनफॉल इंटेंसिटी R विल बी 25.4 A by T plus B, आपको याद है. तो ड्यूरेशन अगर 50 मिनट मतलब ये 20 से 100 मिनट के बीच में है, so R is A is 40, B is 20. You need to remember this. 25.4 into 40 by T is duration, that is 50 plus 20. It's 14.51. Directly you will get the answer in mm per hour. Now your QSWF will be what? AIR by 360. Where A is the area of 100 hectare. I is given as 0.5 entire, so nothing else is required. R is 14.51 by 360. So get the answer as 2.015 meter cube per second. But they're asking what? QWWF, which is QSWF plus QDWF. Most of the students generally commit mistake in this part. Don't get confused. Wet weather flow means the storm weather water flow plus the dry weather flow. That will be your final answer for QWWF. Okay. Let's go for the last question of this chapter, question number 25. Then we'll proceed for the questions of design of sewers. A town with an area 1 kilometer square with a population density 1000 number per hectare. Supplied water. At a rate of 200 LPCD. Out of which 80% reach seaware as a sewage. The town receives an average rainfall intensity Question number 25. A town with an area 1 kilometer square with a population density 1000 number per hectare supplied water at a rate of 200 LPCD, out of which 80% reach seaware as a sewage. The town receives an average rainfall intensity 1.2 centimeter in 24 hours, all of which are runoff. Find DWF and WWF resulting from a community. Area 1 kilometer square, but we require the area in hectare, so that is equals to 10 to the power 6 meter square, and we know that 1 hectare is equals to 10 to the power 4 meter square, so eventually it will be 100 hectare. Population density given as 1000 number per hectare, so actual population will be 1000 into 100 into the power 5. So QDWF, that is population into per capita water demand. Our supply is 200 LPCD provided into 80% factor is 0.8 into 10 to the power minus 3 by 24 into 3600, then only you can get it the meter cube per second. It's 0.185 meter cube per second it will be. 0.185 meter cube per second. Now, it's told that R is receives 1.2 centimeter in 24 hour. It's 12 mm per 24 hour. 0.5 mm per hour. And all the runoff so QSWF it's 139 meter cube per second. So Q WWF will be equals to 0.139 plus 0.185 meter cube per second. 0.324 meter cube per second. Hope you understand the things. Just have a look. The question solved. Let's go for the problems of design of seaware. The theoretical questions is already discussed in this segment. If something is left, we will discuss those also. First question. The flow in a seaware is quite obviously an open channel flow in a closed conduit. Certain portion is blank. Question number 2. Self-cleansing velocity is the minimum velocity of flow required to maintain a certain amount of solids in the flow. First option. Second option, the maximum velocity of flow required to maintain a certain amount of solids in the seaware. Third is such flow velocity as would be sufficient to flush out any deposited solids in a seaware. Obviously, self-cleansing velocity, it is the minimum velocity to required. To job, it will not allow any particle to get settled down. And the second thing it will do is it will take already deposited particle along with it. Option C will be the correct answer. Question number 3. The slope of a 1 meter diameter concrete seaware is 1 in 1000. Develops the velocity 1 meter per second when flowing full. So V is 1 meter per second. For the asking what is the velocity when that's flowing half, I have told you while discussing with you the special cases of half filled seaware that if you remember the case, then lot many questions can be solved within a fraction of second. For this, it will be 1 meter per second. You don't have to calculate anything. Once again, I am repeating the part. The hydraulic radius will be same. Velocity will be the same. Area will be half than the fully flow. And discharge will be half. This fourth thing we need to remember. Question number 4. See a big size statement. 2 marks is there. Get 15 questions. A circular pipe has a diameter of 1 meter, bed slope 1 in 1000, Manning's roughness coefficient equal to 0.01. Manning's roughness, and it may be treated as an open channel flow when it is flowing just full. So lot many things are given. Finally, they are asking what Q full by Q half. The job is done. It's 2. It is Q half by Q full, it will be half. Q full by Q half. Your job is done, it's 2. See how strong the tool is. Go for question number 5. A seaware has a diameter of 300 meter. See, the solution of this question, the way I'm going to solve it, you need to use your calculator at the last moment. So what is V? 1 by n r to the power 2 by 3 s to the power half, which is 1 by n, r is d by 4 for fully filled CVAR, 2 by 3 s to the power half. And you also know that V full is equals to V half. So with that part we don't have to bother about. Slope and diameter both are changing. So only the constant thing is regosity coefficient, that is equals to V by so V is equals by d1 by 4 to the power 2 by 3 s1 to the power half small v half. We can only do it because these velocities are same, v full and v half. That's why we can go for this constant scenario, d2 by 4 to the power 2 by 3 s2 to the power half. We need to find out v half. That is equals to v2 only, or v full for the second case is equals to v1 into, so it's d2 by d1 to the power 2 by 3 s2 by s1 to the power half. d2 by d1, it's double, so it's 2 to the power 2 by 3. No values are required. 2 to the power half. 1.59 meter per second will be your final answer. सर क्लास ले रहा हूँ सर. Next question. Calculate the diameter of a circular sphere this is given. Please be careful about the statement below. Excuse me. I'm repeatedly telling you that be careful about the statement. Let's see the solution process. So capital Q given as 0.05. First, they're asking to find out the diameter. That is equal to capital A into capital V. What is capital A? Pi by 4 d square. And what is capital V? 1 by n. R to the power 2 by 3 s to the power half. This pi by 4 d square into 1 by n d by 4 to the power 2 by 3 s to the power half. Pi by 4 d square is we don't know, that we need to find out. 1 by n given, n value given as 0.013, slope is given 1 in 1000, 0.013 t by 4 to the power 2 by 3. Q from there d will be 0.36 meters. Now it is told when the flow were at 0.6 depth, that is the term, that is the main point of concern. 0.6 डेप्थ, इसका मतलब 0.6 मीटर नहीं, कोई यूनिट नहीं दिया हुआ है. इसका मतलब है depth is 0.6 of capital D. So small d by capital D will be 0.6. So corresponding, if the small d by capital D is 0.6, then corresponding small q by capital Q is 0.54 and it is 0.88. So then small q by capital Q is equals to 0.54. So small q will be 0.54 into 0.05. It's 0.027 meter cube per second, and small v by capital V is given as 0.88. So small v will be 0.88 into 1 by n 0.013 into d by 4 0.36 by 4 to the power 2 by 3 1 by 1000 to the power half. Small v is given as 0.43 meter per second. Hope you understand this question. Please have a look once again. Hope you understand the thing. Let's go for next question. Find the minimum velocity and gradient required. Find the minimum velocity and gradient required to transport sewage with sand particles of 1 millimeter diameter and specific gravity 2.65. Through a sewer of 1 meter diameter. take Manning's n equals to 0.013. Solve it. Diameter of sand particle is given as 1 mm. So minimum velocity is nothing but the self-flinging velocity. So V self 8 beta by F dash is Darcy Weisbach best friction factor. It's 1 into 10 to the power minus 3. G is 2.65 minus 1. It will be 0.656 meter per second, though they have asked for half filled, as the fully filled velocity is equal to the half filled velocity, so no changes will be there. Now they are also asking the slope. So V is equals to 1 by n r to the power 2 by 3 s to the power half 1 by 0.013. R is d by 4 to the power 2 by 3 s to the power half, at V is 0.656 meter per second. where d is given as 1 meter. Give the value as 1 in 2160. You need to express slope in this particular process 1 in something. 1 in 2160 will be your final answer. 1 in 2160 will be your final answer. Next question. A circular sewer of diameter d, if the depth of flow is d by 4, what is the weighted perimeter equals to? One by 2, 1 minus cos theta by 2. So it's, that is the proportional depth. So theta by 2 is cos inverse. So theta is 120 degree. Weighted perimeter is small pw. It is pi d into theta by 360. Pi d into 120 by 360 is pi d by 3 will be your final answer. So these are the major type of questions we have seen for the design of seaware. Quickly have a look. These are the major types. So we have completed the design of sewer and the wastewater flow rates. So from wastewater engineering segment, actually three chapters are left. One is characteristics of sewage, that is the major one. Second one is the primary treatment, and then third one is the activated sludge. Left means the problems are left. That will be done within next 2 days. So next session for Unacademy Combat, just a reminder, that is on 26 January 2021, 6 p.m. These are the launched batches. Target EAC prelims batch B and batch A. 2 batches are launched on 11 January. And don't forget to apply the code SEN10 ACN10. Don't forget to apply the code SEN10 ACN10. Also, don't forget to see the course for this marathon class I've taken last Saturday. It will be really helpful to crack this 10 to 12 marks from your environmental engineering segment. I've already taken it. Don't forget to apply the code SEN10.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
where you put your knowledge to test.
And battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Well, so as of now, goodbye. See you tomorrow with another session.